The title of this talk is Pervasive Location Tracking, a Privacy Protection Perspective. So, let's talk about the future of privacy. If the work at our universities is any indication, we're going to see sensors everywhere. Sensors that see, feel, smell, hear, and communicate. So indeed, we are entering the sensor age. Sensors on and passing through your body will communicate with your phone, your car, your home, and your office, as well as communicate with our travel paths. My wife will be able to turn her TV monitor to the Harlan web channel to monitor where I am along the route home. She'll notice that road sensors say I'm traveling too fast for the wet conditions. My left rear tire pressure is too low. Our daughter's been waiting for me on the corner in the rain for the past 12 minutes. And darling, I see your blood pressure is too high. And I also see that it's rising. Doors to my car and my home will unlock themselves as I approach because they can sense that it's me rather than someone else. So what's the vision for privacy protection in this pervasive sensor and location tracking environment? Well, I want to start by distinguishing between two terms for protecting privacy. Under confidentiality, we allow human identity linking, but we impose a legal obligation to protect. So for instance, in medicine, doctors are required by law not to divulge patient records. In science, we're required by our universities and funding agencies through the institutional review board process not to divulge the identities of our subjects. Now in business, our goal may be to link and track our customers and their activities in the greatest detail possible, but we keep this information confidential as a business asset under trade secret law. So here it's kept confidential primarily to benefit the business rather than to benefit the customer. Well, let's contrast this with anonymity. Under anonymity, we protect privacy by never linking to human identity in the first place. Now, anonymity is a possible option in providing many consumer goods and services, and technologies can be designed and purposefully to not link your identity. And of course, the computer science literature and other sources describe many of these technologies. The problem is that government and business almost always opt for system solutions that track who you are and what you did and then maintain those records long after the purposes of the original queries have been satisfied. So, how do we motivate government and business to not do that? Well, we'll get back to that at the end of this talk. Let's first talk about a practical example in protecting personal information privacy. Now, there are many different kinds of sensors, but let me focus on one specific category. And the category I'm going to focus on is radio frequency ID tags. Here, I'm also going to concentrate only on passive tags. And further, I'm only going to be talking about the ultra-high frequency tags in this general range of passive tags. And I'm focusing on this particular class because these are the tags that are most likely to be deployed widely on consumer products. So, and you notice here that these are, you can actually read them up to approximately 20 feet away. So the challenge here is, how do we design pervasive observation environments allowing protection of privacy without lessening the beneficial uses of these new sensors? Now, the tags I'm talking about are the sensors that will replace barcodes on consumer products. And of course, this will start with tags on high-end products such as expensive cameras and phones, but eventually these will spread to just about everything that carries barcode and probably well beyond. Each tag, as they are currently being deployed, has 96 bits, allowing every consumer object on Earth to have its own unique ID for the next few hundred years. So, will we end up tagging absolutely every single orange? Well, perhaps someday. The limitation right now is the cost. So technologically, it certainly looks possible. What about the size? Well, these tags are often smaller than those individual stickers that you often do see on the apple or orange in the supermarket today. So for example, here's an illustration of Hitachi's current smallest mu chip. This one happens to be for documents that's shown here, and here you see it, the actual size on the end of a fingertip, which is a little small black dot, so that's the actual size of this tag. Now of course the tags that I'm talking about aren't this small at this particular point in time, but certainly this indicates the direction where the industry is going. Now most of these RFID tags can be read through paper and plastic and cloth, so therefore they don't even have to be visible as our barcodes today. Now the idea is, of course, that you'll load up your goods in your plastic grocery cart and you'll wheel the cart through the checkout very much like you drive through Easy Pass on toll roads today. As you come up to the counter, the system bombards your cart with radio waves, and then each tag picks up enough energy to respond back. Now, once they've responded back, up pops the list of goods on the computer terminal or the screen. You say, well, do you agree to pay? If so, you slide through your credit card and you're on your way. These items, of course, are then designated in the database as being sold so that the next time you enter the store wearing those shoes that you purchased on your last visit, you aren't accused of shoplifting. Well, is the technology working? Well, it's certainly not perfect yet, but the industry is getting close. Metal cans and liquids still cause some problems, but new packaging or other techniques can probably resolve most of those. The interference among tag responses has been largely resolved using a singulation protocol. It's typically an ultra-simple tree-walking computational approach that's used. So initial estimates by Walmart is that this technology is indeed very promising and has the potential to save its company alone $1 billion a year. So, if I now want to know what's in my refrigerator, I no longer need to open the door, but simply activate the reader in the refrigerator from anywhere I happen to be sitting in the house. So I might notice that the date on the milk is about to expire, so perhaps we should finish that up today. And oh, look at this, that package of meat in the freezer has been recalled due to mad cow disease. So the idea here again, we'll now be able to track any cow from cradle to consumption. Well, actually even beyond that, because these tags on all of these packages and these tags on our clothing now, once we discard all of these items into the garbage, this could greatly facilitate recycling efforts relative to sorting before disposing in the dump, or actually avoid disposing things in the dump, because it'll be a lot easier to do those recycling efforts. So, do I know, or let's say I want to bake a cake, do I have the ingredients in the house? Or maybe I can ask, what recipes can I prepare due to the ingredients that I do have in the house? So the point is that we'll finally be able to achieve an efficient, smart house. Every ceiling light now comes with an RFID reader, so I can inventory now everything in the house, perhaps for insurance purposes. If I've misplaced my keys, I simply ask the system. It tells me, oh, well, it's on the bureau up in the bedroom, or maybe it's your keys are down in the tool room. And of course, many of you know that car keys today, well, at least many car keys today are coming already with an RFID immobilizer on them. Where's my wallet? Well, perhaps my wallet's in the living room. Most cards in my wallet now will have an RFID tag. Most of those will not be encrypted, but something like your license plate would be encrypted. But again, most of them won't be. Well, what about Fluffy? Yes, certainly we should tag her because she has a tendency to wander, and Grandma, who's been getting a little senile lately, also should probably be tagged. Well, Whether inside or outside, every surveillance camera will now come standard with an RFID reader. So here's an example of a map of several hundred external cameras in Times Square in New York. And I've noticed that downtown Melbourne's concentration isn't that much difference. So now we see somebody on a video camera come walking down the street, perhaps from face recognition. We say, that looks like Harlan coming down the street, and it's his shoes, and it's his coat, and it's his wife's underwear, so it must be Harlan. Well, how far-fetched is this scenario? Well, I should tell you that I worked for a railroad when barcode technologies were first being deployed and developed. And there was an avid corporate discussion at that time about the huge cost of the technology, that it often broke down. It was only 80% correct when the readers were working, and they often weren't working, at least for the railroad that I was working for. And the technological challenges were just too great. This technology was never going to make it. Well, of course, now we know that barcodes are everywhere. So it may take a while, but history shows us that RFID and related sensor technologies are coming, if they're not already here, and their use will be pervasive throughout our communities. And of course, these sensors are going to provide myriad benefits. There are going to be so many potential benefits that we can't even begin to imagine all the benefits currently. But of course, integrated sensor tracking will also provide unprecedented opportunities for clandestine snooping, theft, manipulation, tracking, stalking, profiling, and harassment. Now for me, this immediately raises the question then of who should protect against unwarranted intrusions in ubiquitous spatial tracking environments. Well, one option is to place our faith in government to protect us from these threats. Let's depend on our national, state, and local police, perhaps our campus police, to protect us. But this, of course, raises the specter of intrusive surveillance by government in the name of protecting us from other harms such as terrorists and criminals. By the way, how many of you have electronic tags on your cars for automatically paying tolls in the Melbourne area? Well, I see it's almost everybody in the room. Well, would it surprise you or upset you to learn that your national government has installed hundreds of readers at street intersections throughout the Melbourne area to track those tags not just on the toll roads, but also through all the other street intersections throughout the community? Now, I'm not saying that they have done this, but unless you can point to a specific law banning government from doing this, if you can't point to that law, this tracking may quietly occur as it has in other jurisdictions, right? The practice may not be divulged for national security reasons, for instance. Certainly in the United States, we've seen a proposal in our U.S. Congress for requiring RFIDs on all license plates in the U.S., which again would allow this to occur much, much more efficiently. Okay, well, place our faith in government. But of course, we could also place our faith in the private sector to protect us. In the U.S., this is largely the status quo situation. Where does all the barcode data, for instance, currently go? There are a couple of competing aggregator firms that have detailed data on 300 million Americans in centralized banks of megaservers. So every electronic transaction made in the last 20 years by a typical citizen, such as myself, has been recorded in these records along with their name, the address, and contact information. This data is mined daily to provide services to other businesses on a global basis. And in a post-9/11 world, these data companies are now running data queries for the FBI and police agencies as well. And I'll just reference you to one particular source relative to what is actually going on in the industry. All right. Well, rather than have government or the business elite protect us from threats, why not have your 300 million closest neighbors all have full access to all of this data? After all, we can all watch out for each other and protect and care for each other. That would simply bring us back to the age of the small town where everybody knows everybody else's business. But of course, we don't actually have human contact with those 300 million other people as we did in our small towns. So, as Scrooge said to the ghost of Marley in Dickens' Christmas Carol, answer me one question. Are these the shadows of things that will be, or are they the shadows of things that may be only? So in other words, is there a better way? Can we construct a better privacy protection vision for our emerging pervasive information society? And if so, should this vision be based on legal or moral standards for privacy protection? Right? Well, my answer is that I certainly prefer the moral. Under legal prescriptions, what happens is, of course, is that majority rules and the interests of the minority are not necessarily protected. Then, of course, our information systems operate globally, which causes conflicts of laws among the nations of the world because our laws vary, and we end up with all these jurisdictional problems. Further, laws are designed to require minimal behavior, not laudable behavior. So from my perspective, all of these are very much drawbacks. Ethical theorists over the past couple thousand years have argued that indeed there exists a set of universal principles to which we are all bound, whether in our day-to-day relations with each other or in designing a new information processing environment. So if we were to design morally defensible systems, the laws of most nations would adopt to allow their use. Now, philosophers argue about the exact expression and application, but many of the ethical theories have much in common. And here's one expression of those cross-cutting principles. This set of principles happens to be referred to as the concept of principalism. So in this expression, all of these duties are always in force. So let's assume for the moment we're not just scientists, but we are concerned scientists. How would we design globally pervasive sensor environments that are morally defensible? Well, out of that previous list of duties, I think the greatest challenge for systems designers is supporting this one of those duties that was labeled as supporting autonomy of the individual. Because once you go to that, we start talking in terms of autonomy. Support of autonomy leads us to rejection of one-size-fits-all privacy protection. It also leads us to support freedom to choose your individual privacy comfort level. And it also leads us to support freedom to change your mind at any time and location. Right? It's not a matter of opt-in or opt-out for life in your relationship with some company or agency, but now when we design in this matter, it's a matter of continually opting in and opting out on the fly. Okay? Is this our problem as researchers to solve? And my response is, who better? I'm convinced that the market alone is unlikely to move us in the direction of morally defensible designs, and government itself isn't very good at innovating in these information system design environments. Now, if our goal is to achieve control over the sensors we wear, carry, or own, what are some of the options? Well, one thing we can do is, of course, let's look at technology. Let's protect ourselves through reliance on technology. So I want to set forth a scenario. Let's say we have an unauthorized person who comes and scans the sensors on your body or in your home. This is often referred to as skimming. How could we actually protect against that? Well, number one, we could make the scan ineffective through deactivative tags. And there are ways of doing this, frying, clipping, killing. There are numerous articles on these countermeasures in the computer science literature again. And of course, there are also some temporary means of disabling tags. The problems with this set of technological methods is that when you use them, you lose all or some of the benefits. For instance, if you kill a tag, you can't use it for querying your cupboard or your refrigerator or closet as you want to inventory things within your home, right? It's a benefit to the store perhaps, but then it's no longer a benefit to you when you get those tags home. Well, another issue is that when you use most of these techniques, you may affect the tags of others. So for instance, if you jam or fry all the tag because you're maybe in front of a video camera, you have a device that determines that somebody's trying to read your tag, so then you spread out a means to, let's say, jam the responses. You're also jamming those responses of other people that are trying to use those tags productively, and thus you're impinging on their autonomy to use the technologies the way that they would like to be using the technologies. Okay, well, what are some of the other options? Well, we could make the scan ineffective through encryption and or access control. And again, look to the literature. You'll see all kinds of low-power encryption algorithms that have been developed. You'll also see this encryption or access control can either be contained on or off of the tags in these environments. And certainly encryption is likely to be used where there will continue to exist a legal obligation for confidentiality. Now, what are then some of the problems with encryption? Well, encryption for a class of interoperable sensors is likely to be breakable, right? It's very similar to DVDs. You typically want to use one cipher for all DVDs by a single manufacturer or even across an entire industry, rather than creating a new cipher for each and every DVD. And we know that, of course, those have been hackable by 15-year-olds. So cracking wholesale becomes a very significant risk in this environment, and particularly here where we have these, where the encryption is unlikely to be as strong. Thus, you're going to need extra legal protection, but even that legal protection is not likely to be very effective. Well, what about in the consumer product realm? Well, here encryption is likely to be used on tags on most goods in the long run, right? Because whether I buy products from a grocery store or Walmart or the jewelry store, I want to be able to read all of those and not have to deal with many different encryption algorithms. It simply builds up too much technology overhead, and it also builds up too much legal enforcement overhead in this type of environment. Openness and interoperability win in the ubiquitous service marketplace, and we could cite many examples there. Thus, encryption controls are unlikely to be provided in this consumer context, and that's exactly what we're seeing in the current tag sales. Out of the millions of tags that are being sold today, certainly the vast majority of them are not of the type that can be encrypted. Well, if encryption is not the answer, how about making scans ineffective through a mediator security device? So you might install a Guardian in your cell phone and in every cell phone reader. So your Guardian then detects any read attempts, and if a reader is not approved, your Guardian jams all the time slot responses for your tags and provides spoof responses. Well, what are the problems here? Well, one of the benefits, of course, is that the technique only affects the tags that are being protected. So your Guardian is protecting only your tags, and it's not jamming all the other tags around you, so people can still make use of their tags as they desire. The problem, of course, is that you need to carry the Guardian with you, or you don't obtain any protection. So if you forget your cell phone, again, your wallet and clothing tags might be wide open and available for skimming. Another drawback is that you need an automated or user-friendly process for identifying which tags to protect. This is actually a huge problem as hundreds of tags start to flow into or out of your house, or as you pick up items or carry them and you want to actually protect them. And there's really been no workable solution yet suggested out there in the literature. And then of course we have the spy versus spy problem. If you can jam the jammer, it makes all the tags accessible. Well, because all of the technological approaches have substantial drawbacks, why don't we just place our faith in the marketplace? And of course the theory here is that if privacy is valued by consumers, ubiquitous architectures that protect privacy will prevail. Well, history shows that those companies that voluntarily protect information privacy beyond the legal minimum typically lose in the marketplace, or at least this is a very consistent trend that we have witnessed to date with related technologies. So for instance, grocery discount cards, which are often called loyalty cards, have prevailed very much over privacy protection. Credit cards that tried to protect your privacy but then charged more as a result for their annual service or charged a higher interest rate actually lost very bad in the marketplace. We also spent millions and millions of dollars on voluntary privacy protection technologies for the web that have all failed. So when it comes down to choosing between an immediate cash benefit versus protecting some complex, nebulous, future, non-tangible right, the human response almost universally is, well, I'm going to go ahead and save that $10 on my cart full of groceries rather than, trying to protect myself in the future. So in achieving informed consent or enlightened self-interest is highly questionable under these circumstances. Morally defensible privacy protection has failed to result from dependence on the market alone. Well, if technology and the marketplace by themselves are unlikely to provide autonomy for individuals to decide, how about protecting privacy by passing new laws? So, let's pass one or more laws that would drive technological developments in the market towards morally defensible pervasive location tracking. So by example, let's pass a law that states you may not link people's identity to RFID tags without first obtaining their explicit permission. And well, let's say 90% of the population would support this, and probably they very well would. The Congress passes the law. Looks like problem solved. Well, not so fast. We've actually done this in the United States Congress, and the legislation has been, this type of legislation has been overturned as unconstitutional. This type of, it's been held by the courts to intrude too far on corporate freedom of speech rights, and therefore, again, has been held to be unconstitutional. Well, we can debate this back and forth, we can try to change that law, but perhaps we should just ask the question, well, what has worked within the legal environment? How about if we pass a law which establishes a centralized, legally enforceable do not link registry? Well, how would this work? In this instance, the law would say if a person is registered, you may not link that person's identity to RFID tags without first obtaining their explicit permission. So if this law now exists and I walk in front of a security camera and the face identification routine says that this is Harlan, and the system is also reading let's say 8 RFID tags that came into the view at the same time as I came into view, the security camera isn't allowed to link those 8 items to me in the database because I've now registered myself in the do not link registry. So the same thing would happen at the grocery store. When I buy with a credit card at the grocery store, if my name is contained within the do not link registry, the store is not allowed to tie those purchased items to my actual identity. Okay, this would actually solve the barcode tracking problem over time, since eventually all barcodes would no longer be used. We would be in this new ID environment, and you could actually take back some of the privacy that we have lost in the barcode environment. All right, I think this do not link legal solution has great potential. Most of the benefits of sensors are retained if we would move to this environment. Most of the abuses could be constrained. This approach would actually drive technology towards anonymity rather than confidentiality. And of course, if things are anonymous, it lessens security concerns, because data is not actually linked in the first place, and therefore hackers could not actually get at that information. It also would provide incentives for applications developers to not link, because if you actually don't link, and in many instances you do not need to link to provide a particular service, you would do that because otherwise you would have to keep asking people for permission to overcome the use of that particular instance of the technology. So most developers would try to strive very much to avoid asking for permission. Checking, of course, occurs at the speed of light, just as it does with the do not call list for phones. Automated permissions requests would help enlighten all of us as users. Eventually you might set your default on your phone, yes, I'll always give this permission for this particular application, but certainly, again, you would have the ability to change that option at any time. It's not unconstitutional, or at least our past case law would not hold it to be, and I think is much more morally defensible than the situation that we have today. And I think it's very practical. The do not call list changed practices literally overnight in the United States. And one of the benefits of it is that it's enforced primarily by citizens rather than imposing a burden on the state to enforce. So you have, tens of thousands of attorneys ready and willing out there to sue any companies that would abridge this privacy right for all of our citizens. Well, what are the drawbacks to this particular approach? Well, you need to uniquely identify yourself to government in order to gain the protection, in order to put yourself on that do not link list. But of course, in most societies, we are well down that road anyway. Most of our state driver's licenses are now moving in that direction. Certainly your passports have moved in that direction. So why not take advantage of these national IDs to control linking of records to them? And of course, if we do nothing, the market, technology, and current laws are marching us steadfastly toward pervasive surveillance. So I think this is one way that we could reverse that trend. Is this a good solution for Australia and Europe? Well, my answer, of course, is yes. Some of the benefits are, you folks in Australia right now, you are granting permissions for life to corporations and government. Once you sign on the line, they no longer have to come back and ask you for permission again, because you've got an ongoing relationship with that company. So this would allow you to very much move to this on-the-fly type of changing your permissions whenever desired. And again, the same thing, you would have software developers start to hunt out means to not ask whenever possible. What are some of the differences that we would see in the implementation from Australia to the United States? Well, I think here in Australia, as throughout Europe, you would probably see greater enforcement, greater dependence on government to enforce, whereas in the United States, we would tend to let citizens enforce their own rights, their own privacy rights. Is this a good solution for developing nations? Well, I think it really depends. Can you, in your nation, trust your government to maintain a simple do not link list? Certainly it's been proven that we can do this in most industrialized nations, but can you trust your government in, let's say, some poor nations in Africa? Do you have the infrastructure to electronically check the list? when you are making sales, or those folks with security cameras? And do you have faith in your court system and police to enforce the law? Well, these are very questionable in many environments across the world. However, it is probable, if this technology were to develop to support anonymity in the United States and Europe and other developed nations, I think it's very likely that this technology would spread globally. And certainly in the future, deployment of the Do Not Link list could occur globally rather than nation by nation, as we've done with some other global lists for support of the internet. How would it work technologically? Well, some work has been done on this. I'll provide one reference here, the master's thesis done a couple of years ago, how this would actually work in a kind of a supermarket environment for checking whether you were on the list or not. And this is easily extended into other types of pervasive observation environments. So my research and development challenge for you folks here in the College of Engineering is, let's do it. Develop the sensor information system capabilities to support Do Not Link. They're pulling the technologies together to make it work. I don't think the challenge is actually all that great. I think it's more of a development challenge or an applied research challenge than it is a basic research challenge in this particular instance. So that's the challenge. Do it. And I look forward to a future when some of you have contributed to greater protection for privacy for all of us around the globe.